Alright everybody, welcome back to another video. In this lesson, we're going to be adding a real-time chat feature to our online game using Godot 4 and Golang for the backend. Here's a little screenshot of what we'll be achieving in this lesson. So you can see we've got two Godot 4 clients connected, and they're both chatting with each other using a custom logging chat box. And we're also going to be fixing some of the issues that we might have introduced at the end of the last video. As always, if you want to follow along, but you haven't been able to type the code yourself from the last video, you can always come to the GitHub repository, come down to the releases section, and download the code from the end of lesson 2. In the last video, we ended in a spot where we had a working WebSocket server, but we were unable to connect to it from Godot because we haven't coded any networking stuff in Godot yet. So in this video, we're going to take the Godot chat demo. So you can find that under the official Godot engine demo projects folder. Come over to networking, and they have a WebSocket chat example, and just come into this WebSockets folder and download the, well, we can just copy the relevant parts that we need from this file here. So we're going to be modifying this slightly. So I'm just going to click on copy raw file. And then I'm just going to open up my Godot project, come into this res folder, create new script, and we're just going to call this websockets.gd. Open up the new script and just get rid of this and paste the code from the GitHub repository. So this is the official Godot engine as of version 4 WebSockets client code. So we can go ahead and adapt this to our needs. First of all, we're just going to modify the send signature. So instead of sending a message string, we're going to send a packet. So remember from lesson 1, we created this packets.gd file from the Godot buff plugin. So we can go ahead and use this information to accept a packet in this send signature. So for that, we're going to need to import the packets script. So go ahead and type const packets equals preload res packets.gd. And then we can go ahead and modify the signature of the send method to accept a packet. Packets.packet. And we're just going to get rid of this check here. We're going to replace that with, we're going to convert the packet to bytes. And then we're going to simply send these bytes. But before we do that, remember how I was saying at the end of the last video that we can lazily set the sender ID to just 0 for the client. So whenever the client sends a message, it's always going to say the sender ID was 0, and we just know that that means that it comes from us. So here's where we can do that. So we can just say packet.senderID equals 0. Maybe a better way to do that is set sender ID 0. Now, instead of get message, we're going to rename this to get packet, and we're going to make it return a packet. And here we're just going to replace pretty much everything from here on. So we're just going to say the raw data received was a socket get packet. So the official Godot API calls this a packet, but we're just going to call this data. This is just raw bytes. When we say packet, we mean something slightly different. We mean something like this. We're going to get the data, and we're going to turn that into a packet. So the way to do that in Godot is with packets.packet.new. And we're just going to use the from bytes method on the packet object. We're going to pass in the raw data. And you'll notice that this actually returns an integer. So this will return an error if there was one. So we can go ahead and try to capture that. We can call that result. Then we can just do a quick check. So if result is not just a normal OK status, we can actually just print the error. And then we can go ahead and return the packet. So because we renamed this method and we changed what it returns, we're going to come down to here where we're actually using this method in the poll function. And we're just going to change this to get packet. And we're using this to emit data from a signal called message received. So that's actually defined up here. We're just going to rename this to packet received. And we're going to change the argument to just say packet. And it's going to be of type packets.packet. So then we need to come down here and rename it from here. So now we have a way to poll data and turn it into packets. And then when we receive one, we can emit a signal containing our packet. So other nodes can listen for that signal. We also have a send method, which takes a packet, turns it into bytes, and then sends it across the socket. So that should be everything we need to do in terms of doctoring this WebSockets code from the official repository. It just means that we don't have to write all of this networking code ourselves, just change some of the key features. So because this script is so self-contained, and it should only be used for networking, there only needs to be one instance of this WebSocket client in our game. So this is a good candidate for an autoload or a singleton. So we can register this as a singleton by coming up to project settings, globals, and then just type find the WebSockets.gd. So it says that here under path. And for the node name, we're just going to call it WS, so capital WS. And this is what we can call in our code. So if we type ws dot, it will give us all of our methods, all of our functions that we've defined. So if we click add and then close, this will just make it so that an instance of this WebSockets object is always going to be in our scene tree every time we run the game. So we don't have to worry about adding it to the scene tree ourselves. We can test that out by coming back to our main.gd script. And we might as well just get rid of this test code from the end of lesson 1. Let's go ahead and start using our new singleton. So we can call ws dot connected to server. So this is a signal that gets emitted when we have a connection to the server. We're going to connect that signal to a function in the main script called on WebSocket connected to server. And similarly, we're going to connect the connection closed signal to another function that we're going to define called connection closed. And let's go ahead and connect the packet received signal to another method that we're going to define. Let's go ahead and sketch out these functions. So when we connect to the server, let's just go ahead and create a packet that we're going to send straight away. So we'll just send like a hello world chat message to the server as soon as we're connected. So let's say packet equals packets.packet.new. And we're going to go ahead and create the message itself. So we can call the new chat method on our packet object. And then we can go ahead and set the message on our chat message. We'll just say hello from Godot. And then we can go ahead and send this method using our new WebSockets send function. And we can check to see if there was an error. So this is how we're going to be sending our packet across the WebSocket as soon as we connect to the server. So when the server connection is closed, we can go ahead and just print a simple message. And when we actually receive a packet from the server, we can go ahead and print that as well. So we've set up all of our signal handlers, but we haven't actually connected to the server yet. So let's go ahead and do that in the ready function just after we connect all of these signals. So let's just type connecting to server. And then we can go ahead and use the WebSocket.connect to URL. And we'll give it a URL that we typed into our browser at the end of the last video. So that's just going to be using the WebSockets scheme and then localhost port 8080/WS. So we can go ahead and make sure that our server is running by coming back to VS Code and pressing F5. We see in the debug console here, it says starting server and awaiting client registrations. So let's go ahead and keep that off to the side. And then let's come over here to Godot and press this little run project button. So we see new client connected from my IP address. And we see in the Godot logs as well, it says connecting to server, packet sent successfully. So we don't actually see the packet in the log yet, but we don't have any errors. So that's definitely a good sign. So let's go ahead and print any packets that we receive on the client, on the server side. We'll come to VS Code. Let's come into our WebSockets.go file. And in the last video, we left this method blank, but we're looking for the process method, this process message method. So we can go ahead and actually access the sender ID and the message every time something is received, and we can actually do something with that. So for now, let's just go ahead and print that we've received a message, and we'll print the message out, and we'll just go ahead and echo that message back to the client. So this will be a very simple echo server for the time being. So c.logger.print f received message from. I'm going to use the socket send method. And we're just going to pass in our message. Okay, so now we can just rerun the server by pressing this little restart button up here. And let's try that again. We'll just keep an eye on this output down here, and we'll try connecting. So we can see here it says client 0 received message, received a chat message from the client, and it says echoing back. And then on the Godot side, it says received a packet from the server, hello from Godot. So obviously it's just echoing back what we already sent. So now we have a working echo server, so that's pretty cool. But there's just one problem that I sort of hinted at the sort of in the middle of the last video. And so what happens if two clients connect at the exact same time? So we can sort of test it out by coming up to debug and then customize run instances. And we're just going to click enable multiple instances and click this up to 2. So now if we press the run button, we'll get two clients connecting at the same time. And you can see here, we've hit a bit of an issue. Our previous client was client 0. That was the very first time we opened up this Godot instance. And this is the ID that we've assigned the very first connecting client, because remember, we're using the length of the list. So when we come into hub.go, in the run function, every time we get a new client registering, we initialize them with an ID that's equal to the length of the client's map. So the very first time a client connects, they have an ID of 0 because there's nothing in the map. And then the second time a client connects, they have an ID of 1 because the map only has one other person in it. But if two clients connect at the same time, Go is not going to know quickly enough that there is another person in the client's map. So it's going to think there's only one other person in this map. So both of you guys are going to get an ID of 1. And we can see that here. So client 1 so here we're receiving a message from one of our Godot instances, and it says that they have an ID of 1. And then here it says that we're also receiving a packet from a different instance and they have an ID of 1 as well. So both of these connections, this connection and this connection, they both have an ID of 1, which is going to be a big problem for our server. So this is a common problem when we're dealing with multi-threading and concurrency. This is a kind of race condition where two threads are competing for the same resource. And we definitely need a way to deal with that early on. And I think a really good way to deal with that is by using locking. So when one process is using a resource, it's locked, and any other processes that are trying to access that resource while it's being used will just have to wait. So we're going to go ahead and use a technique like that, but we can make it better. We're obviously going to need a kind of data structure where we have an auto-incrementing ID every time we add a new object to that data structure, and we need a way to access those objects via their ID. So at the moment, we're just using a simple map. We're using a map, mapping IDs to objects, but we can take it a step further and sort of abstract this concept, because we're going to use it later on as well when we are adding objects into our game, like spores or players. We always want to refer to things by their ID because it's most efficient, and we need to make sure that the ID is auto-incrementing, and we need to make sure that we can't get race conditions when multiple clients are trying to access the same resource. So for that, we're going to add a new data structure called shared collection. We're going to do that under the server folder, under internal and server. We're going to make a new folder called objects. And then inside the objects folder, we're going to create a new file called sharedcollection.go. I'm going to say that this file belongs to the objects package. And we're just going to import one package called sync. So this is a good package for dealing with locking and synchronization techniques, which we're definitely going to need in this file. So let's go ahead and define what our data structure is going to look like. So it's going to be a generic thread-safe map of objects with auto-incrementing IDs. So what does that look like? We're going to be able to put any kind of object inside here. So we're going to use the generics. And the underlying data structure is just going to be a map, sort of like what we had before. We're going to be using unsigned 64-bit integers as the IDs. And we're going to use this generic type as the values. We're going to keep track of what the next ID in the map is going to be. And we're going to also need a mutex. So we're going to call this mux. So this is from the sync package. And all this is that this is just like a lock. So you can lock and you can check to see if it's locked before you access a kind of resource. So let's go ahead and define the constructor. We can go ahead and lay down an initial capacity. And this will just make it slightly more efficient. If we know what the capacity of our map is going to be, we can specify it, and it'll just make things a little bit faster. But obviously we can omit the capacity if we don't know what it's going to be, and it'll just start with a basic capacity. So let's go ahead and lay out the underlying data structure. We can check to see if a capacity was specified. We're going to initialize this new object map with the given capacity, and otherwise we'll just give it a default parameter. And then we'll just go ahead and return a new shared collection with the underlying map specified, and the next ID is going to be an ID of 1. So the very first object that gets added to our shared collection is going to have an ID of 1. Let's go ahead and provide a way to add objects to our shared collection. So we're going to be able to pass in an object that we want to add to the map, and we can also optionally specify the ID of the object in that map if we know ahead of time what we want that ID to be. But otherwise we can just omit this ID parameter, and it will return the ID of the object that was added for us for our record keeping. So because we're going to be modifying the shared collection, we're going to go ahead and lock the mutex. And we just want to remember to make sure that we unlock the mutex when we're done with it. And we can just go ahead and say that the ID of the thing that we're going to be adding here is just equal to the shared collection's next ID. But if we did specify an ID in these arguments, we can go ahead and use that. And now we're going to go ahead and actually set the underlying data structure. So when we're using a key of this ID, we're going to set it to a value of the supplied object. And then we're going to increment the next ID, and we're going to go ahead and return the ID that we used. And now let's go ahead and specify a method for removing an object from the map. And we're just going to let Copilot take over here so it already knows sort of what we're going for. If we specify an ID, then we're going to go ahead and delete that from the map. And you can see here that it says if the key wasn't found in the dictionary, then delete is a no op, meaning it just won't do anything. So that's perfect for us. And it would be great if we had a way to loop through every object in our map. So let's go ahead and do that. So we want to call the for each method on our shared collection with a callback. So this callback is going to run, this is a function that's going to get run on every element of the map as it loops through. So the function should take an ID parameter and an object parameter. So while we're looping through the shared collection, we probably don't want to be locking it for that whole time that we're looping through, just because if we have a complex loop, we don't want to be holding the lock longer than we need to, because other processes might want to try to do more basic things like add to the collection or query the collection. So for that, we're just going to go ahead and create a local copy, and then we can unlock the map, and then we can go ahead and use our callback on each element of the copy. We're going to go ahead and lock the map. And then we're going to make a local copy. So we're just making a new map with the same length. And then we're going to loop through each ID and object in the existing map. And we're just going to set the ID of our local copy to that object. And then we can go ahead and unlock the map because we're done with it. We've created our copy. So people are now free to use the map again while we go ahead and iterate over the local copy. We're going to go for ID and object in range local copy. We call the callback using the ID and object as the parameters. Now we're going to need a way to actually get an object from the map. So get an object with the given ID. Otherwise, we're just going to return nil. We're going to also return a true or false, indicating whether or not the object was found. So the get function is going to take an ID and return an object and a boolean. So we're going to lock the map and remember to unlock it when we're done. And then we're just going to return the object and whether or not it was found. So it would be nice if we could get the number of objects in our map. So we're going to have like a length function. And this is going to be useful for us in our project. It's going to be kind of useful. So obviously you want to lock the map before you take the length of it. But I'm not really going to bother here because I know for my project, I'm never actually going to need the precise length of the map. All I'm ever going to need is sort of just like the approximate length. So I'm not going to bother locking, but you can if you know that you need the exact length. It's just that locking will obviously make it a little bit slower. But with that said, let's go ahead and get the approximate number of objects in the map. We're just going to go ahead and return the length of our objects map. And that's it for our custom data structure. We have a way to query the length. We have a way to get an object by its ID. We have a way to loop through the map. We have a way to remove objects and add objects. And we have a way to make a new map as well. So let's go ahead and go back to our hub.go. And instead of just using a naive client's map, let's go ahead and use our new shared collection. So we're going to need to import our objects package. So server internal server objects. And then we're going to come down to here where we've defined our client's map. And instead of being a map of integers to client interfaces, we're going to turn this into a pointer to a shared collection containing client interfaces. And now here we get an error because we're still using the old syntax. So let's go ahead and use our new constructor to make an empty objects shared collection. And let's see. we're going to need to change this slightly. So remember how our add function returns the ID of the object added? Well, that means that we can simply use this. So we can just drop the clients into the map right here, and we can call initialize on the ID that was returned. And here, instead of just setting the ID, instead of just setting them to nil in the old map, we're going to go ahead and just straight up remove them from the new map. So you can do that like this. And here, where we're using the old for loop, we're going to have to rewrite that using our new for each function. So we can do that with h.clients.forEach. Here we're going to specify a function that has an ID, client ID, as well as a client. And then we're going to go ahead and do all of this stuff in the callback. And then we're going to close our for each loop and close the opening parentheses. And we're just going to change this to client ID. Okay, so that's what our new for each loop is going to look like. And we should be done patching hub.go now. But of course we have an error in WebSockets.go because we are still referencing the old client map. So let's go ahead and change this to c.hub.clients.get here ID. So now we can actually go ahead and run the server. So we're awaiting client registrations again. And let's go ahead and rerun our experiment. So I'll close both of these old debug windows. And I'm just going to click this run button again. We've still got the multiple run instances set. So we should see now each client gets their own unique ID. So no matter how many clients I run at once, we should never get any race conditions. So I can even go ahead and set the run instances to 10. So if I press this, we'll get 10 clients connecting all at the same time. And we see here we don't repeat a single ID. So we started at 2 and we ended on 12. We have all of the numbers in between. So our shared collection appears to be working. And we can go ahead and just change the custom run instances to 1, or we can just untick this. And we're going to be reusing this shared collection a few times throughout the project, so it's definitely worth having this here, and we know that it's going to be robust enough for our needs. So now I think it's time to make the client side look a little bit nicer, because currently we're just putting everything into the output console, but it would be cool if we could log things to the screen. So we're going to go ahead and create a new custom log scene in Godot. So we're going to create a new folder. So right click on this res, click new folder, and we're going to call this classes. And we're going to keep all of the reusable scenes that have custom functionality. We're going to keep that in our classes folder. We're going to create a new scene called log.tscn. And for the root node, we're just going to use a rich text label. So this is going to be what drives our custom log. Let's open up our new scene, log.tscn. Click on this 2D view up here. So this is our new log scene. So we're just going to go ahead and set this to take up the entire view. So you can select the rich text label called log. Come up to here where it says anchor presets, and we're just going to choose the full rect preset. We're also just going to make sure that we enable BB code under the inspector when we have the log selected. And we're just also going to set scroll, make sure scroll active is enabled and scroll following as well. So we're going to have stuff in here. So we're going to have stuff printing to the custom log. But we're just going to create a simple script that we can do this programmatically. Oh, excuse me, we should probably put this in its own folder as well. So I'm going to go ahead and create a new folder just called log, and I'm just going to move log.tscn inside the log folder. So it should be classes, log, log.tscn, because then we're also going to create a script called log.gd. Or we can actually right click on the log root node and click attach script. And that'll put it and name it for us. And it'll also tell us that we're inheriting from the rich text label. So that's the better way to do things. We'll just click create. So first thing, we're actually going to give this a class name, just so that it's easy to add this to our scene tree. And we're going to go ahead and make a function called message. And this is just going to log a message to the log. So it's going to take a string. We can also give it a color. And we're going to make this color just a default of white. And we're just going to use the append text method from the rich text label, which just parses BB code and adds it to the stack. So let's go ahead and do that. And if you're not familiar with BB code, it's kind of like an old standard that was used a lot on like message forums back in the day. But it's just like a set of cool tags that you can add to your text. So you can put tags in square brackets here. I can actually show you if we come back to this 2D scene. So if my message was hello world, looks pretty plain and boring. But if I add maybe color tag, let's go with like a nice green color. And if I close that tag, then suddenly I have a green hello world. And you can do all sorts of really cool stuff we can get into later on. But yeah, this is BB code. So we're going to be taking advantage of that in our script. So we're going to say color equals hashtag, and then this is going to be the placeholder for our color that we pass in. And then this is going to be the placeholder for the message that we pass in. We're going to go ahead and close the color tag. And we're going to use color.toHTML. And we're not going to use any alpha, so we'll set that to false. So this is our message function. And we're just going to use this as the backend for a bunch of other auxiliary functions that we're going to actually expose to the outside. So the most basic one is just going to be called info. So this is just going to be for logging information. And we're simply just going to call message using our message. And we're just going to use a color of white for a basic info message. I'm just going to copy this, paste, and let's go ahead and define a warning message. So this will be used whenever we want to write something that is not quite an error, but it's probably something that we want to stand out. And we'll just use a yellow for that font. We'll go ahead and provide an error message as well. And we can use orange, red. We can also define a success method, which is going to stand out to be something good that's happened. So we'll print that in green. And we're also just going to provide a chat method as well. So this will just be sort of like a custom logger that will also print the name of the sender. So it's going to take a sender name as well as a message, and we're going to format it like this. So the sender part is going to have its own color. And then the message is going to be in italics. So we can use the I tag in BB code for that. I'm going to use this nice blue color for the sender's name. And then we're going to go ahead and call the .toHTML. So by the way, this toHTML method just prints it in a kind of string that the BB code expects. So kind of like this. So the second formatted argument should be the sender's name, and then the final one is going to be the message. So yeah, this will be the color, this will be the sender name, and then this will be the message. So we can actually go ahead and test that out. So we'll add a log to the main scene. So we'll come over to main.tscn. So we're going to want to change the root node. Instead of a log2d, we want to make this like a control node. When we add UI elements, things are going to behave a lot better. So we'll just change the type on the node 2d. We'll just make this a control node. And we'll just rename this to main. So now we can go ahead and add a child node. and we can make it a log. Because we gave it a class name, we can search for it here. And then we're just going to go ahead and put it down sort of towards the bottom. And we'll just put it down like that. It doesn't really matter at this stage. We'll just save the new main scene like that. So now in our main.gd script, we can actually go ahead and refer to our new log. So just underneath where we've defined our packets, let's go ahead and make an onReady var. We'll call this log. And we can either click and drag the log node, and that will give it the unique identifier that we can use to refer to it from the scene tree. Or we can just type $, and it'll give us like some autocomplete suggestions. And just to help out the static type checker, we can cast this as a log type. So now we're just going to replace all of our print statements with log statements. So we're going to do log.info for connecting to the server. Let's go ahead and do log.error when we had an error sending the packet, or maybe log.success for when we actually sent the packet successfully. Maybe log.warning for when the connection was closed, and maybe log.info for receiving a packet from the server. And so I'm just getting a little error saying it can't find log in the current scope, which is kind of strange because we are in the main scene. So I'm just going to go ahead and stop the running project because maybe that can help. Save that again, and the error seems to have gone away. So I'm just going to start the server back up again by pressing F5 in VS Code until I see awaiting registrations. Then I can come back here and run my project with the custom logger. You can see here, it looks a lot better. Although we're missing something very important, which is the new lines. So let's go ahead and make sure that we put new lines in our message function. So you can just do that with \n. So let's try that again. We can see now everything is on its own separate line. So that's looking a lot better. And let's see. If I stop the server halfway through, we get like a little yellow warning saying connection closed. So that seems to all be working as expected. So we're actually pretty close to having a fully working chat room, believe it or not. All we really need to do is go ahead and add some packet handling logic to the server. And we also need to handle the responses on the client. Let's go ahead and handle the server-side logic first. So we're going to revisit our process message method on the WebSocket.go. And instead of just logging and echoing back any message that was received, we're just going to go ahead and make an if statement based on the sender ID. So if the sender ID was ourselves, meaning it came straight from our version of the Godot client, we're just going to go ahead and broadcast that message to everybody else on the server. We can use the broadcast method on the client interfacer. We're just going to send that to the hub's broadcast channel, and then that's going to be processed by every other client interfacer that's connected. Otherwise, if we are processing this as a way that this has actually been broadcasted to us, we're just going to go ahead and forward it directly to our own client. And we just use the socket send as method to inject the sender ID of the person who sent that message and deliver it straight to Godot 4. So we have a way of broadcasting messages that we send and delivering messages that were broadcast by other people. The only other thing that we're going to want to do is send the ID to the client as soon as it's assigned. We can do that here in the initialize method. So after we set the logging prefix, let's go ahead and send a new packet. we're going to use our helper method that we defined. We're going to use packets.newID. I'm going to use our own ID. So remember, this is what we made in the first lesson. This is just a wrapper for creating a new ID packet. We can go ahead and log the fact that we've sent the client their ID. All right, so now we can actually go ahead and on the Godot side of things, we can listen for those IDs. So let's go ahead and change our main.gd's handler for when we connected to the WebSocket server. So instead of sending a hello world packet, we're just going to go ahead and log a success message. And we're also going to replace what we have on the received handler. So when we receive a packet from the server, what are we going to do? Well, we should probably do different things depending on what kind of packet we received. So first of all, we're going to keep track of the sender ID. Packet.get sender ID. And then we're just going to go ahead and say if the packet has a ID message. So basically, if this was an ID message that is telling us what our ID is going to be, we can go ahead and create a new handler for that. We can use the packet.getID to get the exact message from the packet. And this is a method that we haven't defined yet, but we'll go ahead and do that in a minute. Else, if the packet was a chat packet, we'll go ahead and handle that as a chat packet. So this is just a nice little place to keep all of our packet handling logic in one spot, but then we can go ahead and create new functions. So I'm going to go and make a new function called handle ID message. I'm going to use the packets.id message type for this. And we're just going to maybe create, maybe we're just going to log our client ID. All right, so that's looking pretty good. And now let's go ahead and define our handler for the chat messages. And we can go ahead and just use our chat message that we defined on our log object. So the sender's name, we're just going to say is client placeholder, and we're going to just use the sender ID. And for the message, we're just going to get the message from the chat message. Cool, so we have a way to interpret messages on the client. We just need a way to actually send messages. So we're going to come back to our main scene, and we're going to add a new node of type line edit. We're just going to go ahead and make this take up the top of the screen like that. And we're going to come back to our main script, and we're going to keep a reference to our line edit node. You can just drag that here like that as line edit. And then let's go ahead and connect to the line edit's text submitted signal to a new handler. Text submitted. So this is just a signal that gets emitted every time the user presses enter inside the line edit. And it expects a string called new text. On line edit text submitted. It's going to be the name of our handler function. We just need to make sure that it accepts a new text string. And let's go ahead and actually send that message and also log it to our personal log. So we're going to create a new packet for the chat packet. We're going to go ahead and make the chat message from that packet. New chat. And then we'll set the message on the chat message. And we'll use the new text. So this is the text that was in the line edit when the user pressed enter. We can try to send that over the WebSocket. And if there was an error, then we can simply log it. Otherwise, we can go ahead and log a new chat. And the sender name is just going to be you, because you're the person that sent that. And we'll use the text that we submitted, new text. And then we can just go ahead and clear the line edit. So this is just a clear function here. And it's just giving us an error saying text submitted was called as a function. So I kind of bodged the syntax on that a little bit. So we actually want to do text submitted.connect. And then that's our handler passed into the connect function. So we should actually be able to go ahead and run this. So let's restart the server. And I'm just going to come back to the debug custom run instances, and I'm going to enable 2 run instances just so I can easily have a side by side. We can see here on the left, we have client ID number 1. So we're actually receiving our ID properly. And then on the right, likewise, we're receiving our ID message correctly and interpreting it as such. Let's go ahead and send a message from client 1. And we can see from the perspective of client 1, it just says you said hello client 2. And from the perspective of client 2, it says client 1 said hello client 2. We can go ahead and say hello back. And we have a working chat room now. That's pretty cool. We've made some pretty good progress. So yeah, like I said, having a chat room is a pretty good first step for an MMO. We've got pretty much just like a real-time messaging system built on a Golang backend and a Godot 4 front end. We fixed a major issue with our server, so everything should be nice and robust. And we made our own custom log, which is going to be really useful for throughout the whole project. So we've achieved quite a lot, and these early videos are pretty long and dry because there's a lot of foundational setup to do. But we've only got a little bit more of that foundations to set up before we start coding our actual game logic. So in the next video, we're going to be enhancing the message handling logic on the server and client. So we're going to be introducing something called state machines. We're going to be using the state pattern to better organize our logic. And that's going to help us in future episodes where we're going to be building more and more complex mechanics on top of existing states. If you have any questions, you can come over to our Godot MMO course Discord server, and we can all work together on that. So until then, I'll see you next time and have a great day.